So, hello students. Today we are going to learn part 13 of chapter number 8, that is trigonometry of class 10. In this part we are going to learn some more examples on trigonometric identities. Okay, so let us start. So already we have started proving that LHS equal to RHS type examples. So here we have next type of example. Now here it is given that prove that 1 plus sec A upon sec A equals to sine square A upon 1 minus cos A. Okay. Now you can either consider LHS first, then you can find RHS and then prove it together. So in this example, we are going to use that method. Okay. So let us consider LHS first. So LHS equals to, now what is LHS? So LHS is equal to 1 plus sec A upon sec A. Now we have to see whether we can make use of any identity or not. So right now no identity is possible for this one. But we have a trigonometric ratio, that is sec A can be written as 1 upon cos A. So instead of this sec A, we will write cos A 1 upon cos A, and here also we will use 1 upon cos A. Okay. So now we get this one as it is over here plus here, and this sec a, instead of this sec a we have written 1 upon cos a. Okay, and instead of this sec a also we will get 1 upon cos a. Now in next step what we are going to do, this cos a will multiply to 1, so cos a into 1 will be cos a plus this one as it is. Okay, so we will get in next step as cos a plus 1 upon cos a, and the denominator as it is. Okay, now here it can be seen that we can cancel this cos a and cos a. Okay, or if you want you can bring it in the numerator also. So in next step you get it in this way. Okay. Now here what happened, this cos a will multiply to the numerator and this one will multiply to this cos a. So we get here cos a in bracket. Now cos a plus 1 can be written as 1 plus cos a for our convenience. Now this cos a and this cos a, it will be cancelled. Okay, we can easily cancel. Why? Because they are divided. Okay, so in next step what we get now, what will be remaining here, 1 plus cos a. Okay, so our answer will be 1 plus cos a. Now this is what our LHS part. Okay, we cannot solve further than this one. Okay? So we'll keep it as it is. Okay, so this value we got it as 1 plus cos a. Now sorry, now we'll consider the RHS part. Now what is RHS part? So it is sine square a upon 1 minus cos a. Okay, so let us write here RHS. So now RHS equals to sine square a upon 1 minus cos a. Now this sine square a, we have seen an identity that sine square a plus cos square a equals to 1. Okay, let me write that identity for you people. We have seen that sine square a plus cos square a equals to 1. So if we change the side of this cos square a, we get it as sine square a equals to 1 minus cos square a. Okay, so now we will use this identity over here. So instead of this sine square a, we will write 1 minus cos square a. So in next step we get it as 1 minus cos square a upon this 1 minus cos a as it is. Okay, now this 1 minus cos square a means it is nothing but 1 square minus cos square a. So that is of the form a square minus b square. Okay, now a square minus b square can be written as a plus b, a minus b. So in next step we can write it as, so what we have done, instead of this one a square minus b square, that is 1 square minus cos square a, we have written it as a minus b, a plus b by using this identity. Okay, our denominator is as it is. Now here it can be seen that this 1 minus cos a and this 1 minus cos a, we can cancel it. Okay, so when we cancel it, finally what do we get? We get it as equal to 1 plus cos a. Okay, here. Now, here we can see that LHS is also 1 plus cos A, RHS is also 1 plus cos A. So, we can write it as, since LHS equals to RHS, therefore this 1 plus sec a upon sec a is equal to sine square upon 1 minus cos a is proof. Okay, so in this way also we can solve these examples. Now let us consider a different type of example. Now here it is given as prove that under root 1 plus sine a upon 1 minus sine a equals to sec a plus tan a. Okay, so let us consider LHS first. Now what is LHS here? We have under root 1 plus sine a upon 1 minus sine a. Now here what we will do, we have learned a topic that is rationalizing the denominator. In the first chapter we have learned. Okay, in the previous class also we have learned. Okay, so that property we are going to use over here. Okay, now for rationalizing the denominator, here it is 1 minus sine a, so we will multiply it by 1 plus sine a. Our first term will be as it is. Sorry, so this 1 plus sine a upon 1 minus sine a will be as it is. Now by what we will multiply? The numerator and denominator, so we will multiply it by 1 plus sine a. Okay, so what do we get? 1 minus sine a. By this number we have multiplied, so 1 minus sine a, 1 minus sine a. Now when we multiply over here, what do we get now? It can be seen in numerator it is 1 plus sine a into 1 minus sine a. Now it is of what form? A plus b, a minus b. So a plus b, a minus b can be written as a square minus b square. So that we have written over here. Okay, just a minute. Here we have to multiply it by 1 plus sine a, 1 plus sine a. Then it will be correct. Okay. So now in numerator what we are getting? 1 plus sine a, 1 plus sine a. So it will become 1 plus sine a bracket square. And the denominator is of the form 1 minus sine a, 1 plus sine a. That is a minus b, a plus b. So it can be written as a square minus b square. Now this 1 square means 1. So we kept it as it is. Now this 1 minus sine square a, already we have seen a formula that we know that sine square a plus cos square a equals to 1. Therefore cos square a equals to 1 minus sine square a. So instead of this 1 minus sine square a, we can directly write here cos square a. Okay, so in next step what we get? Our numerator, this 1 plus sine a bracket square as it is, but instead of this denominator, now what we can write? We can write there cos square a. Now remember that the numerator is also having square, that is power 2, denominator is also having power 2, so we can take square root, we can remove this root now. So when we remove this root, in next step we get it as 1 plus sine a, that is this one 1 plus sine a upon cos a. Now this cos a is denominator for both 1 at the same time for the sine a, so we can separate the denominators, separate the numerators. Okay, so what we get over here? We get it as 1 upon cos a plus sine a upon cos a. So this cos a we have written for this one also and for this sine a also. Now what is 1 upon cos a? So 1 upon cos a is nothing but sec a, and what is sine a upon cos a? So it is nothing but tan a. So finally we get sec a plus tan a, so that is nothing but equal to our RHS. Okay, so this we have to prove. So in this way we have proved that LHS equals to RHS. Okay, so this much is enough for today. Thank you. Have a nice day.